So I'm
It's a little tricky.
a little nervous. So when I tell her I was up in the office looking
Walk away.
Yeah, I'm gonna wait for you.
Okay, well, it's made of this.
Hey, Aaron, how are you?
but it's easier to do so.
Just not good.
Okay, welcome to our, wait a minute, I gotta get the go-ahead from Pete. It's sort of 4, 3, 2, what'd you say? Go ahead. Okay, welcome to our weather discussion. We do this every Friday from 12:15 to about 1 o'clock. I want to just remind you of all the ground rules. It's informal, bring your lunch. Nobody has to raise their hand to make a comment or ask a question. And as the semester goes on, other people will be leading this discussion. It won't always be me. And I appreciate their assistance. So some of them know who they are, and that's the way it's going to be. I think that's enough for the ground rules. We meet every Friday, I might have said that. We even will meet on the Friday just as spring break begins, but we won't outside of the academic year, except when the weather gets exciting. Which, just about at the end of the academic year, it gets really exciting in a place known as Tornado Alley. So we may well find ourselves here. I'm starting today's discussion with a picture from Mohi City in northeastern China, right on the border with Russia. And Mongolia is to the west. Okay, and Lake Baikal is about 200 miles away. This town set the all-time Chinese low temperature record on Sunday, the morning of the Lunar New Year. This year was let me get it right, minus 63.4 degrees Fahrenheit. It's never been colder than that in China. But amazingly, it's gotten close to that in China, in this same place. So this is known as China's North Pole. Now imagine all of the circumstances that have to go into it getting to minus 63 degrees Fahrenheit. And this was at the end of a very long cold spell, which has implications for the weather for us for the next couple of weeks in some way or another. I'm not ready to say what those implications are or how they're connected, but I can say a couple of interesting things. So here's a picture of a building in China's North Pole, as they call it. It's well lit. I don't think it's only 3 feet high. So this is probably 3 feet of snow or 4 feet of snow and then 3 more feet above the snow. So this is a place where when it snows, it doesn't melt. It just stays cold all year. It's deeply in the middle of the continent. Lake Baikal, of course, has a thick ice cover every single winter inside in Russia. And this is not far away from it. And so you get a sense that you have to have a radiative blanket that effectively takes the ground completely out of the picture. And that's probably been the case, I don't know, since mid-October in a place like this. I've asked Tristan many times, what is the threshold depth of snow which makes the ground invisible in the infrared? And he's never answered, but he's always been interested, as he always is. He's interested in everything. But I bet it's not much. I bet it's about 1 inch or 2. So once you put the first inch or 2 down in a place like this, you get more and more radiative cooling every single night. The night gets longer for a very long time, and you just produce extraordinarily cold air masses. And you're at 57-ish degrees, I think, north latitude in this city, so it's way, way up there. And this is the breeding ground for the air that descends over the Korean Peninsula, that descends over the Sea of Japan, and is part and parcel of the way enormous developments can get going along the Kuroshio. So minus 63.4. And what was the other place? A place in Siberia had its coldest temperatures in 25 years with the same cold spell. So a really deep cold spell over northeastern China, far northeastern China, and eastern Russia was something that was in the news late last week into the late part of the weekend. The thing I want to point out is that, and I don't have anything to show you about this, but it's in a paper I wrote in 2015 about the cold pool at 850. From December, January, and February, if you do a correlation of the actual 850 millibar temperature and the aerial extent of the hemispheric cold pool, then the place that shows up as the most strongly correlated with an expansion of the cold pool is the area just to the northwest of Beijing. So this is not quite in it, but something about cold air masses getting developed in sort of northern and maybe northwestern, northeastern China near Lake Baikal in Russia is correlated with an expansion of the cold pool across the hemisphere during the wintertime. It gets increasingly correlated in February, less so in January, and even less so in December. So one gets a sense that this is a place where when it gets cold here, something's going to happen around the hemisphere. I'm really interested to see whether or not that's true this year. Pete, if we could go to my PDF to start that off. So a cozy place. I'd love to be there. I have to say, I'd love to be there. Here's the time series of the 850 millibar cold pool aerial extent from December 1st of this year up till yesterday, January 26th. And so here's the long-term average from the NCEP reanalysis. So 75-year average now, plus 1 standard deviation, minus 1, and then these are the all-time minimum and maximum for each calendar day. So you get an idea of how this has gone over these 75 years. The beginning of that cold outbreak, or cold spell in Russia and in parts of Mongolia and northeastern China was right around the 20th of January. And that's about at that point right there. So I'm not prepared to say there's anything causative here, but it does seem to conform to at least what shows up in the long-term statistics, that when it gets really cold there, the hemispheric cold pool expands. And so that's happening, although in the current day, an expansion gets you to minus 1 standard deviation below the average for the hemisphere. This time series is quite interesting. It's one of the interesting ones out of the 75. A really big expansion of the cold pool in mid-December. It kind of coincided with one of our first cold spells of the year. But we didn't get desperately cold here, but it got cold in a lot of places. Then extraordinary volatility, but pretty much surrounding about 67-ish million square kilometers. That's not, of course, common. It's supposed to go up for this whole same period. And so this is now currently the 12th warmest December 1 to January 26th by this measure in the last 75 years. So it's, and Liam, I updated it from our conversation yesterday. So this little spike right here is the last 7 days. But this is the tail of the tape so far this year. So I don't think, when you're 12th warmest, you're not going to be the warmest. That's not going to happen. So this is sort of like a Cubs season. You know, you win 75 games, you don't make the playoffs, and nobody really cares. They pretend they do, but they don't care because they expect it. So this is the, being 12th on a list of 75 is not that great. So I'm a little disappointed by that. But we still have February, and some interesting things could still happen, I suppose. But we won't get to the top spot. That's just too far out of reach. Okay, so I don't know if this new increase, it's been one of several, has anything to do with that long-standing historical sort of correlation. I doubt it, but it's interesting to me nonetheless. Okay, let's go now to more proximate weather across the, thank you, Pete. Let's take a look at our satellite image movie across the continental United States and adjacent waters from this morning. And this is the corrected reflectance, false color, whatever you call it, but it's cool, isn't it? You really see some nice things. Really intense cyclone. They're not uncommon here in the southern tip of Greenland. But look at the front cloud band extending all the way down to Havana. And then up here to, Reykjavik's over here. And so you've got the southern tip of Greenland is where the cloud head of the storm that's dragging clouds across Havana, Cuba is. That's impressive. Now, I don't mean to talk down to tropical cyclones. You know that I like them. They're okay. But come on. That's pretty impressive. In fact, you could probably make the argument that you've got cloudiness on the Yucatan. That's tied to this. That's awesome. Okay, that's all I'll say. I think that wins. But really awesome. And then you can't see so well in the visible the obvious structure, though, to this little Alberta clipper that's kind of slid by us this morning. And it gave us intermittent heavy snow showers and then lighter ones and so on. And what a week. It's been a wintry week. Not desperately cold. But a little bit of sprinkle of snow every day. And I'll say, well forecasted. Everybody knew that was coming. And so that's a tremendous testament to where we are in 2023 compared to where we were in 1983. You would never have been able to say the next 5 days are going to be a sprinkle of snow with any confidence. In fact, that would have been looked upon as a hedging forecast instead of an actual, well thought out forecast as it is in this case. So we'll take a look at this maybe in the infrared because you can see the structure a little bit better. And then there's another system that's also difficult to find, partly because the clouds are so bright white and the underlying snow is white, so you can't really differentiate. But there's another one that's over the Intermountain West, maybe leaning toward the Pacific Northwest. That's kind of a nice looking system. That one I think is going to move to our south over the weekend. And then building up, what you can't see at all here, building up is some really exceptionally cold air. I don't know if it's made its way across from the eastern to the western hemisphere. So in other words, I don't know if it has its origin in the Lake Baikal region or not. Usually that isn't true, but it might not, but it may be in this case. But anyway, it's going to be very, very cold. Earlier this week, it appeared that a forecast for a week from today was putting us in maybe the minus 15 to minus 25 range. It looks to me as though the really big slug of the cold air moves off to the north and east. It's going to be northern Maine and far eastern Canada that really gets hammered under current forecasts as they sit today. And my guess is they're better informed, and so one in the modern era trusts them. They're better than they were 5 days ago. They have to be. We have resolved something that was not resolved at that time. So they come into a better resolution. Okay, Pete, could we take a look at the infrared so we can see a little more of that?
You were talking about having a hard time seeing the weather systems over the snow. The day cloud band RGB might be illustrative of that as well. So we can take a look at that. And the other thing I wanted to point out about this is check out how this sort of mirrors the outline of the.
Oh yeah, sure it does.
You can see, the bay there and the.
Yeah.
This looks kind of
Very interesting.
Even this little notch here shows up.
Yeah, one imagines, I don't know if it's right, but one imagines this is just colder and drier, more importantly drier air spilling off the continent slowly and coming off in a fairly coherent front line. Yeah, which makes that boundary in the stratocumulus obvious. Yeah, really interesting.
Okay, we'll go to the infrared first.
Yeah, okay, thank you. So you can see a little bit more here. Now, one thing you see in all this dark blue and green, much of this is just cold air, because the infrared is seeing temperatures around 250 K at the top of the atmosphere or something like, or in the middle of the atmosphere maybe. And so you're seeing the presence of the cold air. But this is clearly a disturbance on top of that is quite separate from it. And now we're getting, at the end of this, we're at noontime, so about 20 or so minutes ago. And so these little fingers of cloudiness in here are the ones that I think we'll see when we look at the radar reflectivity are tied to some of those heavier snow showers. And now it's all over as we go by. So we want to try and understand a little bit more about this cyclone. It's really interesting storm, fairly weak, but this is exactly emblematic of the kind that piles up our snowbanks here in Madison. We don't get 12-inch snowfalls here. We get 12 2-inch snowfalls. And you end up with 20 inches of accumulation over a period of 2 weeks. That's kind of how things go here a lot of the time. Look at how cold the cloud tops are of this beast that's on the south coast of Greenland. That's beautiful, isn't it? Absolutely spectacular for that. And then you can see a lot more structure to this disturbance here over parts of Idaho moving into Wyoming. And in fact, a really coherent back edge to the cloudiness, at least the cold clouds here associated perhaps with the cold front of this structure. But it starts to get mangled when it comes across the high terrain of Utah and Nevada. I don't know to what extent that mangling has occurred, but it's remarkably well put together in the infrared satellite presentation, even with that transect.
You can also see a little bit of snow across the Cap Rock in western Texas there from the system earlier this week.
Oh, right in here, yeah. That's interesting, yeah. Yeah. And Lubbock's right south of that, right?
Yeah.
So did they get snow in Lubbock?
I'm not sure. I didn't look at the observations.
Yeah,
but-
interesting. Okay, that's pretty far south for them to get
Yeah.
snow. But I'm sure Governor Abbott will have it all in hand. Don't have to worry about that. Let's take a look now at the next rep.
I'm going to pull up that day cloud if I've got it.
Oh, yeah, you can educate me on this, Pete.
I don't have it there. I've got it in the CONUS area. It's this day cloud phase distinction. It only works during the day. It uses different bands for the red, green, and blue. So the red band is infrared, the green is one of the visible channels, and the blue is one of the visible channels. So it really only is valid during the day, which is why in the night period, like on the West Coast, it's red early on because it's dark there and all you're seeing is the red channel. But it helps you to see the bright green that you see in the middle of the country is snow, and that shows up in Texas really well.
Oh, yeah.
The light blue are low liquid clouds, like lower stratus or lower atmosphere water clouds. The yellow going into red are higher ice clouds typically, and then the dark blue is like land, and then the black is water. So it kind of helps you to identify the differences between higher clouds, lower clouds, snow, clear land, a little bit better than just the visible.
Yeah, you sure can't see the cloudiness in the orange or red. I wonder if some of the heavier snow around 9 o'clock was just seeded of the stratocumulus underneath the dendritic generation here in this. And that would show up better in the radar reflectivity too, I
think so,
suspect.
yeah.
So you'd know you have more dendrites falling through the supercooled water, but it's interesting.
So yeah, if you want to learn more about that, there's a link right next to it with the PDF file that explains what goes into it and how to interpret the different colors that you see. Oops, that's the air mass one, but same idea for this one. It'll give you an idea of what the different colors mean and how it's put together and why they use those. So,
Okay.
anyways,
Thanks. Let's
Yep.
take a look at the national radar. I don't think we've done that yet. So there's a lot of detail in this radar of this system passing over us. You can see that's probably one of the heavier snow bands, and there's one just to our south, probably snowing reasonably heavily in Janesville right now, not here in Madison. And that's probably the last one for this complex. In a minute, we'll look at the distribution of at least the quasi-geostrophic vertical motions in the middle troposphere, 700 millibars, in association with this passage. And you're going to see a region of general ascent followed by a region of general descent that you can really pick apart nicely. And it shows up in perfect coordination with what we see both on the satellite as well as the radar. So it's a nice diagnostic. And then I don't know if this is a lake effect band that's coming off across the eastern part of Lake Ontario, but that's the Syracuse Tug Hill Plateau area. So that's probably pretty interesting as well. Okay, and that is about it for the satellite. Let's take a look at some upper level charts now. I would go to the West Coast satellite image, but it's dominated by this anticyclone right off the coast. And everything's kind of mixed up, not really well put together anywhere around and to the east of the date line. So it's not such an exciting map to look at today, so that's why I won't do it. Staggeringly low geopotential heights at 500 millibars here over the southern part of the archipelago in Canada. 47, 48, temperature minus 43. We saw colder in December. Didn't we see minus 50 at 500?
Yeah.
We got minus 48 at Resolute. I don't know if that's Resolute, I'm making it up. But you better be Resolute if you're living there. That's really cold at 500 millibars, but not as cold as we saw earlier. But a really beautiful climatological Hudson Bay low. It's just about where it should be, with little, always is the case, little vorticity features, little waves on its periphery. And one of them gave rise to our snow this morning. That's so obviously the case. We don't know if there's anything resolved along the chain of lakes in Canada, or unresolved in the chain of lakes. It doesn't look like the baroclinicity is very strong. It's minus 44, up here in Northwest Territories at minus 36, up there in BC. So that's not a strong temperature contrast. Were it a strong temperature contrast, I'd be worried there's plenty of little vortices there waiting to be baked, turned in the northwesterly flow to the next Alberta Clipper type system that'll come across us. I don't see evidence of that here, so I think that's probably not the case. But on the East Coast, where we saw that cloud mass going all the way from southern Florida up to Greenland, which is right here, look at this temperature contrast at 500 millibars. It's minus 14 near, can't think of the town. It's not, it's in North Carolina, south of Cape Hatteras. And then it's minus 18 further inland. That doesn't look so great, but minus 27 in Charleston, West Virginia. That's a strong horizontal temperature contrast. The analysis seems to want to, and it's minus 28 up there in Newfoundland, and probably a lot warmer at Cape Breton Island. So that's a strong and lengthy horizontal temperature contrast at 500 millibars. That'll coincide nicely with a pretty strong jet we'll see when we go to 300, I think. But a couple of little waves here that are in the flow, and the one to our west at 12Z this morning was perfectly aligned to give us that snow burst in the morning. Big anticyclone over the eastern part of the Pacific Basin, forcing the flow forward into northern and actually almost the North Slope of Alaska, and then straight southward into the Intermountain West. That makes it easy for cold air that might mass in this part of Canada to find its way southward. And that's what will be the threat in the coming week. We'll take a look at that. Can we look at 850 millibars?
is this just a really unusual map for 500 millibars? I don't remember, and maybe I've just missed it, but I don't remember ever seeing a map where the entire North American continent was dominated by one giant cutoff low.
Yeah, if it's going to happen, it happens right now. This is the coldest day of the year, maybe tomorrow is, in the 850 cold pool in the Northern Hemisphere. So this is when you reach your maximum extent climatologically, not every year. And so that means that the continents have to be as cold as they're going to be, because you don't build up that area over the ocean. So in a broad, blur your eyes sense, maybe it isn't so crazy. What's interesting is the bookending anticyclones are really extraordinary meridional amplitude. More so over here on this, with the storm that's gone all the way up into the Greenland, Iceland area, the Greenland Sea. That's a tremendous ridge that goes all the way up almost to Reykjavik. These heights will be at 5,700 meters. It's what you get in the middle of the summer in Omaha.
Yeah.
So pretty wild. And then in between, it's just a really deep and expansive, great cold spot, really is what it is.
Yeah.
So yeah, pretty interesting. So it might be a blurry version of climatology, a little bit enhanced compared to maybe the normal situation. So here's at 850. Here's our geopotential height minimum just over International Falls. If I had drawn this myself, knowing what I would like to portray, I would have shown this baroclinic zone kind of the same as it is here. Nice cold frontal baroclinic zone on the backside of the cyclone. And then this is a little bit better organized, I think, in reality than in the drawing. The warm frontal, warm advection region. It's -5 at Dubuque, or south of Dubuque, I guess that's Moline. And then -13 in Gaylord. And so there's a really sizable temperature contrast here that I think is underdrawn. And I think you can say the same here. It's 0 at Lincoln. It's -11 near Detroit. So that baroclinic zone is stronger than analyzed here, I think. And the consequence is the warm advection is stronger. And I think that means that the cloudiness is more easily forced, the precipitation is more easily forced, and it's a really, probably a better looking Alberta Clipper system than the way the analysis portrays it here. But anyway, that's just what I'm seeing in some of the observations. I think I would make this look a little bit more intense. So the -7 at near Champaign takes a little bit of the wind out of my sails. But nonetheless, over the state of Wisconsin, I think the warm advection is a little stronger. And Posh and I noticed a mix with, I think, raindrops. I don't think we were imagining it on the way over to lecture at 11 o'clock. So last night at 10 p.m., it was 11 degrees outside my house. This morning at 6, it was 19. I'm willing to bet it's 31 to 33 now at home. And that's not going to happen with kind of modest warm advection. It's going to happen with pretty strong warm advection, though. So I think that's probably underdone. So that's what it looks like at 850. Let's see if we see a hint of that at 700 feet.
We got a comment on the stream from Benji Johnson, who says that was Wilmington in North Carolina you were looking for.
Of course it was. Benji knows every station. Thank you, Benji.
We're going to 700?
Yeah. What's the 5-letter WMO identifier of Mohi, China? Let's see if he can get it.
Okay.
Probably will.
That's for you. He's about 45 seconds behind us.
Which means he'll have it in 2 seconds. So here's the 700 millibar version of the cold frontal baroclinic. So it looks the same, doesn't it? And then at the 700 millibar version of the warm frontal zone, it does have this bulge to the north, just like it did at 850. So I don't know, maybe I'm imagining that it's a stronger signal than it actually is. So anyway, but broadly speaking, the upper trough is to our west at 7 a.m., and that's a perfect place to be if you want ascent. And it doesn't hurt to have a little bit of warm advection mixed in. So every one of the levels looks the same. Now let's take a look at 300 millibars to get a sense of where the polar level jet is. And wow, look at that. So this is 1, 2, 3. The third white color is 90, 170, right?
I think so.
Yeah, we're in 150 to 170 range right in there. I think that's 180 at Cape Hatteras, or north of Cape Hatteras, I'm sorry. That's in Virginia. And so this jet goes all the way from northern Mexico up to, there's the southern tip of Greenland, and it's still moving toward Iceland. So that's an impressive boundary for the front edge of this desperately cold air that's kind of been massing over the Western Hemisphere. Very interesting. And with the ridge busting up into Alaska, there's, in the northwesterly flow, there's a tendency for intensification of these jet maxima. There'll be some ascent right in here, and so you can imagine a little bit of a carve out of a trough there. I think this next one here is the one that was tied to the cloud mass we saw this morning. So there might be yet another disturbance that shows up in the Pacific Northwest tomorrow, maybe, or into the day on Sunday. Very impressive. Let's go to 200 millibars. Remembering that we're at 180 knots, right in there.
You stumped him on the China. He said we'll have to ask the Google on that one.
Ah, man, I thought he'd know off the top of his head. I'm not disappointed, Benji. I'm just surprised. Okay, here we are. Here we are at 200 millibars, 160. So it was stronger winds at 300, which means that's like a polar jet core, and 180 knot polar jet core. That's really something else. Just remarkable. I'm tempted. In fact, we're going to do it, Pete, if you don't mind. Can we go to? Is it pivotal to let me do cross sections? This is tropical. Lets me do cross sections.
Right.
And let's just see what the structure of that thing is. And that was 12Z, so we'll go to 12Z. Yeah.
It's the right model run. That's like right now, right? You wanna?
Yeah, so let's go right here. Let's do a cross-section right there.
And it's shift or control?
I think it's control. Yeah, perfect. Maybe it'll argue that you went off the board, but let's see.
You want probably PV?
Yeah, let's look at the PV and the jet. It's a little bit of a blind look, but there's the 180 knot, or 120, I guess it is. It's not quite as deep, but look at that upper front that comes out of that feature. It goes all the way down to 625 millibars or so. That's pretty impressive. Maybe it's even elderly, decrepit a little bit, but it's still a pretty intense feature. Look at the incredible horizontal and vertical shear in there. It's just beautiful, isn't it? And it's almost a one-step tropopause jump. That's like the subtropical tropopause at 150 millibars. That's definitely the polar tropopause. And it's hard to imagine that there's more than one step there. It looks like one to the next. So this might be a superposed jet, or it had a history of being such. So anyway, that's kind of cool. Glad you can do that so quickly on the fly. It's so nice. But they need to impose a smoother on this. That would be my complaint. So, okay, what are we going to do next? Oh yeah, let's take a look at, so we try to make a sense of where this cloud mass and the weak disturbance that came through us came from by just looking at the upper level map. Let's go to my omega page. It's the only place I know where we have smooth omega, even though it's QG. Boy, I had more arguments with Louis Uccellini about that in Denver. And he just hates the quasi-geostrophic system now. I don't know what happened to him, but I'm kidding. Louis, if you're watching, we can argue in person in October. We're having the 75th anniversary of our department, founding in October of this year. So please put it on your calendar. It's going to be really fun.
6th and 7th, right? That weekend.
6th and 7th. The idea will be we'll have some programming late in the day on Thursday, the 5th. We'll have the weather discussion on the 6th, which is a Friday, and other programming. Then a big banquet on the 7th, somewhere on campus. We have several places. I think we're going to use the DeLuca Forum, actually, now I think. So it's going to be really great. So please come. Okay, let's go to, this is made at 0Z. I'm going to talk to you people about something's going wrong. So this is valid this morning at 7 a.m. Where it's yellow, these are contours of upward vertical motion, and these are contours of downward vertical motion. 500 to 900 thickness is the dotted white lines. So one gets an idea about the thermal structure. So here, you can see the little wave in the thermal structure is coincident with ascent on the downstream side and descent on the upstream side. And at 12Z this morning, we were kind of in a region of weak ascent. If we were up in southeastern or southwestern Ontario, it would have been stronger ascent and probably better snow. But now if we go 6 hours ahead from here, which will be more like now, you'll see, and it's a forecast valid now. Here we are in Madison, and it's just about right on target. The vertical motion is more intense in Ontario, which is interesting. The descent is not any different, but the whole thing has progressed further to the east and put us out of the range of any substantial forcing for ascent, so I think the snow is over for us. But it's a beautiful example of this, how if you get this couplet of vertical motion, you're going to distort the thermal field in such a way as to produce a thermal ridge where the air is ascending and a thermal trough where it's descending. And then you can show that with the QVEC.
Caleb and I were just noting, it looks like, is that couplet of vertical motion offshore of Greenland kind of the opposite orientation of what you expect?
Oh, this here, I forget now where the storm is at this time. This might be a new disturbance. This might be the descent from the older one that's now further to the east. I don't know. That's a good point. That's a good point. Okay, so one more, Pete. We can just see, we'll go to 24 hours. I just want to see what happens to that vertical motion.
Jeff Hawkins chimed in and said it's actually Morehead City, North Carolina.
Oh, Morehead City. I've been there before. Yeah.
So,
Okay.
thanks, Jeff.
So it stays about as intense, but you can see we're flooded with a fairly consistent elephant ear-shaped region of subsidence that comes over us. And so this is all over for us now. In fact, I think the sky's even brightening, so all of that seems right in line with it. But again, I really like how the thermal field responds to the ascent and descent couplets this way, and it makes me certain that we've got a long isotropic Q-vector convergence that's driving most of it. In fact, there's a way to test that. At this time, Pete, can we take a look at that partition? So here's the, we were at 24 hours. Here's the long isotrope part of the vertical motion. It looks like the largest piece of both, and let's see what the frontal part looks like. And that's the transverse of 24 hours. Yeah, there's a little bit in both. This is like the cold frontal subsidence. There's a little bit of maybe a set below the threshold of the contour interval, and then this is maybe the warm frontal cloud head, but it's a smaller fraction of the total. So that tends to be the case for these kinds of storms, and it's nice that it worked out in this one. Okay, one thing we do want to take a look at for the forecast is the impending cold. But before we do that, one other thing. I do want to go to Alicia Bentley's maps over the Pacific Basin. There's going to be a really interesting development that goes on tonight and tomorrow that's well worth attention. There we go. So if we go to North Pacific, and on this, we'll just look at this series of charts. So here's a really intense 250 millibar jet coming across southern Japan, but really Hawaii's here, and this is the date line. That jet is wildly retracted. Okay, that's a very strongly westward retracted jet, and so that's one of the modes of variability of the Pacific jet. How will it evolve is an interesting question, and on what time frame. But right at the exit region, or nearly at the exit region of that, is the development of this system that's to the southeast of Tokyo. And so let's see, that's 1,840, that's 996. So that's a pretty modest disturbance at 12Z this morning. We clicked through these a few times, Pete. So you can see that thing gets really nicely wrapped up. That's 12 hours later. This is now, one more will be 24 hours later. And we're down in the 948, I think, range at that point. The jet has still stubbornly refused to make much eastward progress, but there's a really intense baroclinic zone, beautiful thermal structure to this thing. The thickness lines in blue and red are giving me insight about that. Let's, right where you'd expect it, a stubby little jet, right in the right exit region of the jet, perfect place to develop. Let's go a little further. And even more development, look at that. And then pretty much that's the end of it, at the development, not the end of the storm. You don't want to be in a boat out here, though. I mean, look at that pressure gradient. These are every 4 millibars. Well, there must be 60 or 80 foot seas there. Isaac.
It's really interesting. We were talking about in 453 yesterday that there was another similar cyclogenesis event in the Sea of Japan that kind of had a similar synoptic setup, I think, to this, that I think broke a lot of snowfall records in Japan earlier.
You know the Japan Sapporo region? Do you know?
Ian, where was that Japan record?
Oh, yeah, Northern Ireland. Yeah,
Yeah,
yeah.
I can remember exactly what it was, yeah.
That's awesome. And of course, that has some relationship to the extraordinary cold that we talked about to begin the discussion. So, because that's lake effect enhanced, it's extremely enhanced. Because it's like those hot towers. The air is so cold that you get these spinning columns that form cyclones. This one, I think, is tied to this synoptic, a very large synoptic scale. But it, there's going to be other things that drop huge amounts of snow on the northern islands of Japan that don't really necessarily have that kind of a synoptic evolution. So my eye was drawn to this one. One of the things that's cool about this storm is that here's the cyclone center. This is not really a concentrated baroclinic zone in the southerly flow. So where do you place the warm front? There are storms like this, and I don't know how to define them better than that, but November of 1998 here in the continental U.S. was just like this. There's no obvious warm frontal structure to it. There's an intense cold front and a thermal ridge, but there's no obvious warm front. There's just kind of a broad region of the same temperature gradient. Not the same advection, but the same temperature gradient. They seem like a different class, and maybe they have a certain relationship to the large-scale environment that determines that characteristic. I don't know what it is, but if I had another lifetime, I'd spend some more time thinking about that. I've got other things I unfortunately have to do now. So that's kind of neat. Let's go back to our, go a few more times, Pete. I just want to see what happens to the jet. This storm will be kind of shed from the jet as we go forward. It just goes up to the Sea of Okhotsk. And the jet, here's the date line again, keep on going. It really struggles to extend. Now what it needs, of course, is a cyclone either in the Gulf of Alaska or one over the Aleutians to produce the right pressure gradient that'll allow the jet to move further east. So if you keep building storms and deepening troughs in the far eastern Pacific or western Pacific, you're not going to allow that to happen. And that's kind of what's going on here. So I'm immediately wondering, is it the intensity of the cold over continental Asia that maybe contributes to a succession of events that prohibit the jet from extending? because the extended jet is more the climatological norm, and this retracted one is not. So anyway, we've been thinking about this in my group for a long time, nature of the Pacific jet variability. And now I'm starting to think, how is it related to other synoptic features that might be characteristic of certain environments like this one. I want to just show a couple of overhead slides of the vertical motion distribution associated with this. So we can go back to my page if you have it still. Yeah, let's go to the North Pacific then, Pete. Again, the same forecast made by the GFS. Let's start at 12 hours. That'll be about now, and that was kind of roughly what we saw with Alicia Bentley's maps. This is a really intense upward vertical motion maxima just off the coast of Japan, the southeast of Tokyo. That's where the cyclone's developing, and then you can see the thermal structure again. Let's go ahead 6 hours. We had pretty rapid, or 12 hours. Let's go to 24. That's halfway through the rapid development period. And that's pretty intense vertical motion, now stronger subsidence, and then Japan's left back to the west. Let's go again, 12 more hours. Look at this, I mean, this is unbelievable. It's almost like a solid yellow and a solid blue here, this contrast of vertical motions. I won't count in here, but I think it's something on the order of 22 or 23 centimeters per second, synoptic scale updraft. That's unbelievable, and probably just as much synoptic scale downdraft. And the couplet is really interesting. I find that in these developments, you start out with a couplet that's oriented from 9 to 3 o'clock, and then they rotate counterclockwise. They get to about 12:06, and that's about where it ends. It doesn't go any further than that, and I don't really know why, but it seems to be characteristic. But really intense ascent. This is when the cyclone's evacuating tremendous amounts of mass aloft, and the pressure's getting down into the 950s. And let's split this up. Let's just see what this thing is composed of at this time. So this is at 36 hours. Let's see what the long isotrope Q vector part of it is. Whoa, it's pretty big. But it's not the whole thing. As you can see, these are not solid yellow and solid blue. It's not the whole thing. And this little appendage that comes down along the cold front is missing. Let's see what the transverse part of it is. This is the part that's the cross isotrope Q vector, which is tied directly to the quasi-geostrophic frontogenesis. And boy, do you see that. Look at that. Strip all the way along the front edge of the cold front, and then a really intense maximum right near the cyclone center, and then a little bit of a stubbiness. It's a stubby warm front, as we saw in the prior thing, that goes out to the east and the southeast. And then here's the subsidence back behind the cold front, so ascent and descent straddling the shear, just as it should be. Ascent and descent straddling the shear in the northwest quadrant of the cyclone. Really, really nice picture. And then one last partition of this, Pete. First, let's look at the Sutcliffe portion of the omega. This is just PVA, NBA by the thermal wind. Looks almost the same as the long isotrope Q vector part. They're very closely related mathematically, but they're not identical. And then we can split this up, since it's the vorticity advection by the thermal wind. We can take a look at how the shear vorticity is being moved around by the thermal wind, and how the curvature vorticity is being moved around. They add together to produce this. So let's see which one's bigger in this case. So here's the shear vorticity advection. So it's just vorticity that arises from horizontal differences in wind speed, not curvature. Strong couplet and smaller, very small scale, intensely small scale. But right above the cyclone is where the ascent is, and right to the south of that is where the descent is. And then for some reason, we get some ascent in the cold air from shear advection by the thermal wind. Let's take a look at the curvature. Much bigger scale. I didn't count, but I think about the same magnitudes, but the scale is always bigger of the curvature vorticity advection. So it kind of strikes me that it produces the large components of the structure of the cyclone, the big cloud head, and then the big clearing behind the cold front. And then you add on top of that some mesoscale structure from the shear vorticity that really drives you over the finish line for intense cyclogenesis. But notice in every case, the couplets are aligned 12 to 6. They don't vary from that. So anyway, that's going to be an interesting storm. And this will be Saturday noontime. So you can watch this instead of the football games on your computer. So there's no games of interest anymore. So. Let's now take a look at the The last element will be just taking how cold they're going to get and when. So let's take a look, Pete, at your Python maps over the, maybe we'll get the 104 grid. And we'll just look at 850. We'll just kind of click through them one at a time. So let's take a look at 12 hours. So this will be tonight. So you can see there's some pretty cold air that's massing here. We saw this in some of the analyses before. There's the cyclone that earlier today was crossing across the Arrowhead, and it's moved into northeastern Ontario. And behind it, nothing but cold advection at 850. We start out here in the lightest purple there, which is something like minus 12-ish degrees at 850. I forget what the off was. It was in that range. So that's about minus 12 for us over Madison, and we can get as desperately cold as like minus 26, minus 28. This is freezing cold air. This is in the minus 38 range at 850. So really, really cold. So let's see what happens 12 hours from here. This would be 7 p.m. tonight. The next one will be 7 a.m. tomorrow. Madison, not much has changed. The cold advection has kind of infiltrated right along the border and made it colder in northern Minnesota, northern North Dakota, parts of the upper peninsula, but it hasn't really changed much in Madison. So maybe there's still some yet to come. Very strong winds from the north, but not much temperature contrast across, sort of Manitoba, but the temperature gradient is a little bit stronger to the south. This is the thing that I think loomed large for next week, but it doesn't any longer. Let's go 12 more hours. This will get us to 7 p.m. tomorrow night. And you see a little bit of a cold tongue that kind of moves southward along the Rocky Mountains. And then there's going to be a pressure trough and a wind direction change along that. So that's going to be developing into some sort of a front, probably somewhat stationary for a while, but not for long. And then warm advection to the south, less warm advection to the north means differential warm advection. I don't know, maybe we see a little bit of snow on Saturday. It's certainly cold enough, and there ought to be forcing for ascent in the vicinity. And the source of that air is not exactly from the arid southwest, it's from the western part of the Gulf of Mexico. So we might see a little snow on Sunday. Let's go a day ahead from here, Pete, if we could.
So that's Saturday night?
That's Saturday night.
6 o'clock actually this time of year.
Yeah, right.
This would be Sunday morning. 6
Yeah, that's
o'clock.
Sunday morning. So the baroclinic zone has made slight southward progress, probably puts us out of any precipitation region. Not so maybe for Kenosha, Rockford, places like that. So even into Sunday morning is a threat. It's not zero threat for us, but it's less of a threat. Let's go a whole day from here. I want to see what happens to this cold air mass to the west of Churchill, Manitoba. So that lobe sort of swings around at the base of this broad cutoff, and it does make us a little bit cold. Well, not us, maybe La Crosse, Minneapolis, places north of us, a little bit colder by the time we get to Monday morning. We're certainly colder then than we are now, but not in an entirely different category. It's not frigid middle of the Arctic winter. Let's go another day ahead, so Tuesday morning. So this is Tuesday morning. There's lobe number 1. It's slipped across us during the day Monday, and we're a little warmer on Tuesday than we were on Monday. Here's the really dangerously cold air on the northwestern shore of Hudson Bay. Where does it go? Let's just take a one day at a time quick look at it. I don't want to belabor it, but you can see starting out on the western shore of Hudson Bay, now it's on the south shore of Hudson Bay, the same longitude as us. It doesn't look good for us getting it, which I think is a good thing. But a minus 39 at 850. And so let's go one more day ahead. You can see why there was a threat for us to get desperately cold. Whoever gets visited by this cold air mass will remember it. But we probably will not be visited by it, and therefore we won't remember it. So, if you're in the Plains of Abraham, Quebec City, watch out. Okay? That's going to be brutal on Friday. One more day. Let's just see exactly where ground zero is in maritime Canada. Oh, yeah. I'd say Quebec City and to the north. Anacostia Island, and that's going to be really cold. I think we're at minus 41 at 850 millibars there. Deep cyclone develops offshore as the cold air comes in there. There's Greenland, just to remind yourself, Labrador Sea. Part of the deal here in the Labrador Sea is you got to make the water cold so you can spur that convection. This doesn't hurt. To bring this kind of air over the Labrador Sea. I always ask my oceanography colleagues, how important is that? And I never get a satisfactory answer. But what that means is I won't be satisfied until I know that the very cold air is what drives the thermohaline circulation. And that's probably not true, so I'll never get that answer. But I think it contributes. It's got to be part of the story. And it's going to be windy here too, so it evaporates and cools too. So there's all sorts of cool things going on there with these outbreaks. And if they don't happen anymore for one reason or another, what does that do to the circulation? It's got to have an impact, but I don't know how much. So please don't take away from my comments that I don't think my oceanography colleagues are giving my question any concern. They just know that it's not that important, and I wish it were. So, but look at, we're back to warmer by the time we get to next Friday than we are right now. So the Friday next week Friday threat is really, doesn't look like it's really a threat. So that's good. Watch this. Oh boy. And we just missed it. But we stay in this broad warm advection zone. That's the thing I kind of do like about this. When you're on the southwestern periphery of such a thing, you can't help but stay in a warm advection zone, and that means snow flurries, probably for us. Again, most of the week next week, unless it climbs above zero.
It's getting close near the end there.
Yeah, it does get
light
close
blue
near the
color
end.
is 0.
And the hemispheric view, which we don't need to show, but I looked at it myself. This is the cold air in the hemisphere, the whole northern hemisphere. So the eastern hemisphere has kind of evaporated away after the deep cold event. And there's a new one maybe brewing, but it's very hard to brew new cold air after February 1 because the sun's up. So, you know, the factory starts to shut down. It's about over. I'd say by Valentine's Day, it's over. You don't make any more cold air. You just move it around at that point and modify it. So thanks, Pete, for driving. And next week, we'll meet at the same time. I'm not sure who will be running the discussion, but it may not be me. I can't be certain of that, but it may not be. So thanks for your attention, and I look forward to seeing you next week. And Pete, thanks again.
There is a cyclone in the next week.
I said it was dirt.
Oh, yeah.
West Coast.